Good evening, students. Now in this video I'm trying to explain you some problems which is based on superposition principle. In the previous video I explained you what is superposition principle and I solved two problems also, but in this video we are having four different situations. This is the question. Consider the situation as shown in the following diagram. Find net gravitational force on the particle of mass small m. So let us see the first figure. Here we have a small m, and rather than this small m we are having two more masses, that is one is capital M and one is 2m. So we need to find the net force on small m. So I'll start solving very first problem, so have a look and try to understand it. So as you can see, here we have basically three particles. One is small m, right? Then here we have B point, here we have 2m, and here we have A point, here we have capital M. Distance between these two is d, and this is also d, and this distance between these two will be 2d. Now you can see here this small m is under the influence of two masses, that is capital M and capital 2m. So definitely this mass capital M, this will exert force in this way. So let us say this is the force because of A on small m, so this is Fa. Similarly, the force because of mass which is present at point B on small m will also go like this, and that will be we can say that is equals to how much? Fb. Okay, so what we are observing, we are having two forces, Fa and Fb, and these two are acting in the same direction. So we can say the net force, that is F net, is equals to Fa plus Fb. Now to find this F net we need the value of what? Fa, and we need Fb. So we first find Fa and we find Fb. By Coulomb's law, by gravitational law, we know that Fa, force between any two mass bodies, is given by G into m1 into m2 by r square, right? So here m1 Fa is between these two, so m1 is capital M and m2 is small m, and distance between these two is 2d, so 2d ka square will be 4d square. This is, let's say this is equation number 1, this is equation number 2. Similarly, we will find Fb. Now as you can see, Fb is force because of B, that is 2m, on small m. So Fb will be equal to G into, by same gravitational law, that is small m into capital 2m, by, here the distance between these two is d, so we can write it as d square. This is equation number 3, right? Now as we can see here, the equation 1, we will substitute these two values in equation 1, so we will be getting F net is equals to Fa. What is Fa? It is G capital M small m by 4d square plus G, right, 2G small m capital M by d square. Now here denominator is 4d square, so you can multiply these terms by 4, divide by 4, so 4 2s are 8, so it will become G capital M small m by 4d square plus 4 2s are 8 G capital M small m by 4d square. Denominator is same, so numerator will get added, and this will be equal to 9 G capital M small m by 4d square. So this is the net force acting at particular mass small m because of these two particles having mass m and 2m. So this is your first problem. I hope you all understood, right? Now we'll see the second problem. Now what is second problem? See here in second problem, here we have mass 36m, here we have small m, here we have 64m. So we'll draw the diagram and we'll try to understand it. See here we have, this is a one right angle triangle situation. Here we have 36m, point named as A. Here we have point B, which is a position of small m. Here we have point C, which is a position of 64m, and this distance is 8d, this distance is 6d. And I hope you all can understand one thing, that this small m is under the influence of these two masses, so this is again will exert force in this way. So we can say this is one force, this is Fa, and this is another force, that is Fc, because of C on B. So these two are mutually perpendicular, so resultant force will be acting in this way, and this we can obtain by the help of parallelogram law. Okay, so now we can write, this is my F net. Okay, so we can write F net is equals to under root of, what is that, FA ka square plus FC ka square plus 2FA into FC into cos of theta. Here the angle between these two FA and FC component is theta equal to 90 degree. So this theta will be 90, so this term is going to be 0, and we can write F net is equals to under root of FA ka square plus what, FC ka square. Now to get this resultant net force, we need to get FA and we need to get FC. So we'll try to get the value of Fa. Now look at, again, remember gravitational law. What is force between two particles? It is G into m1 into m2 by r square. So Fa is this force between these two. So G into, let us say m1 is 36m. So 36m into m2 is what? Small m. So small m by r square. R is 60. So that is 36d square. So this 36 cancel, and we got Fa is equals to G into capital M small m by d square. This is the value of Fa. Take it as 2. Similarly, we'll get the value of what? We'll get the value of what? Fb. So as you can see, Fb, again we can find Fb. So what is Fb? Fb is force between this Fc, sorry. This is Fc. So Fc will be force between what? This 64m and this small m. So these two we can get again by gravitational law. And what is that? G into 64m into small m by that d square. How much is that? That is 8d. So that is 64d square. So this 64 cancel, and we got Fc is equal to G into capital M into small m by d square. This is, you treat it as equation number 3. Now if you look at equation number 2, what is equation number 2? It is G m by d square. And what is equation number 3? Same. So for convenience, we will take Fa is equals to Fc is equals to F, so that our calculation inside the root becomes easy. So F net is equal to under root of F square plus F square, because that term is already 0 because of that. So root 2F. Now what is the value of F we got? It is G into capital M into small m by d square. So this is the net force acting at small m because of 64m and 36m. Okay, now we'll see the third situation, and we'll try to solve the third situation. Now have a look here. What is third problem? Third problem is little bit, you have to pay attention. See here, this third problem. In third problem we are having here capital M. This is capital M, this is capital M, and here we have small m. Okay, so now look at here. See, now we have this distance as d and this distance as d. This is d by 2 and this is d by 2. Okay, this is A, this is B, this is C, and let's say this point as d. Now here is your small m. As you all can see, this m, along the same line two masses are there. So because of this capital M, the force on this small m will be acting, let's say, like this. So give the name as Fb. Similarly, the force acting on small m because of mass at C will go like this, right? So give this Fc. Means at a point D, and one force will be acting like this. Okay, so this is Fa. So these two, this mass is same, here also mass is same, this distance and this distance is same. So these two are equal and opposite. So it is following Newton's third law, action reaction pair, because of which the net force because of this B and C at small m is going to be 0. So only the remaining force which is acting at point small m, mass small m, is because of the mass which is present at A. So we can say the resultant force will act at small m is because of mass capital M at A, and it is acting along dA. Fine. So first we'll find along BC. Along BC बोले तो ये, तो इसमें हम क्या देख रहे हैं कि ये स्मॉल m है, इसका पास में इधर से एक मास है, इधर से एक मास, इसका फोर्स समझो ऐसे गया, तो हम उसको लिखते हैं FB का वैल्यू क्या होगा? G कैपिटल M स्मॉल m बाय d by 2 का स्क्वायर, d square by 4, that is 4 will go to numerator. Similarly FC is again same, 4g capital M small m by d square. So along BC में the net force will be, if you take this as positive, this as negative, that along BC it is equal to FB minus FC. So FBC is equals to 0. So one thing is clear, that along BC, this diagonal, along this direction, no force is acting, only force acting is along this direction. Okay, so what is that force? We'll find FA. What is FA? G M, capital M into small m by distance. This distance is what? AD. This distance is what? AD. So we'll write here AD square. But we don't know AD square, so we can find it by the help of Pythagoras theorem. And by Pythagoras theorem, AD is equals to under root of d square, hypotenuse square, minus base square, minus d square by 4. So this should be root 3 d by 2. So this we got it as root 3 d by 2. We can substitute here. So FA is equal to G capital M small m by AD square. What is AD square? That is 3 d square by 4. 4 will go to numerator. So FA is 4 G capital M small m by 3d square. This is the net force at point small m, that is on small m mass along DA. I hope you understood all the three problems. Now we'll see the fourth problem. The fourth problem is, what is that fourth problem? The fourth problem is we have a one square base system. So this is a square base system. Okay, now we have 4 points. So this is your small m target point where you need to find the force. Okay, little bit adjustments I have to do. So this is small m, this is 4m, this is you have 3m, and this is 2m. This point is A, this point is B, this point is C, this point is D, and all distances square, so D. We need to find net force at small m, because all the questions are like that only. We need to find that is net force at small m. So this is my small m. Look at here, this small m is under the action of 4 masses. So if three masses further rather than this small m, we have 3 masses. So these 3 masses will definitely exert some force on this small m. Let us say because of D, the force on A will be going like this. So give the name of this as FAD, force on A because of D. Similarly, the force on B, A because of B will go like this, and this we can say as FAB. Okay, as we can see, these two are perpendicular, so the resultant of these two will go in this way, and this resultant we can name it as FBD. Why FBD? क्योंकि यहाँ पे B और D का फोर्स आ रहा है, तो उन दोनों का रिजल्टेंट को हमने FBD ले लिया. उस तो हमको क्या दिख रहा है बेटा? What we are looking here, that A दोनों resultant is FBD. So similarly, one force is left here now. So that force is also act like this. So this is also force, and this is because of C. So this is FAC. So how many forces finally acting at this particular point A, that is small m, FAC and FBD. So net force at A is equal to sum of FAC plus FBD. Why sum? Because they both are along same direction. That is same diagonal. So we need to get FAC, we need to get FBD. Okay. Now what is FAC? So FAC is force between A and C. So this distance, this is D, this is D. So D square plus D square will be 2D square. So this will be root 2D. So we can get FAC now. What is FAC? FAC is equal to G M1, that is 3M, M2 small m by R square, that is root 2D ka square, that will be 2D square. So this become FAC is equal to 3G M square by 2D square. This we got FAC. Similarly, we can find FBD. Now what is FBD? FBD is a combination of FAB and FAD. So by parallelogram law. So by parallelogram law, if you try to find, how will you get? It will be component, first component FAD square plus FAB square plus 2 FAB cos theta. Now here theta value is 90 degree because these two are mutually perpendicular. So it is equal to under root of FAD ka square plus FAB ka square, and this term is going to be 0 because cos theta, cos 90 is going to be 0. So to get the value of FBD, we need to first get the value of FAD and FAB. So FAD, what is FAD? FAD, you can see here, FAD is force between A and D. So distance is D. So this is equal to G into M into 4M by D square. So this is equal to 4G M square by D square. Similarly, we can find FAB. FAB is 2, this is B and A. So this will be g into m into 2m by d square. This is equals to be you can say 2g m square by d square. Alright, now in both the terms you can see this part is common, so we can treat that part as a f, so for convenience, for make it easy, and this is 2f. Now put the value in FBD. FBD is equals to under root of, what is that? Under root of FAD. FAD is 4f ka square, that is 16f ka square. 2 ka square will be 2f square will be that is 2f ka square will be 4f square. So this will be under root of 16 plus 4 it is 20f square. So this is equal to root 20 f. Root 20 f is how much? G m square by d square. This is the value of FBD. Now we got FBD also and we got FAC also, so we can get FA. So what is the value of FA we have? FA is equals to FAC, that is FAC is what? FAC how much we got? 3 g m square by 2d square plus FBD is root 20 gm square by d square. We can take gm square by d square common, right? Inside the bracket 3 by 2 plus root 20. So this is the answer. So in all the 4 problems we have got the values, net force. Okay, I hope you all understood all these 4 problems. In next video I'll try some more problems of extended bodies. In all these problems what we have discussed till now, it consists of point bodies. In next video we'll see the extended bodies, and for extended bodies, that is rod and that type of body, how we are going to find the net gravitational force. I hope you all understood. Thank you, and we'll see next things in next video. Thank you.